Hi everyone. Suppose you have an application load balancer ALB handling traffic for your application. Now imagine users start reporting connectivity issues or unexpected traffic patterns. At this point, you might want to answer questions like which IP addresses are actually reaching my load balancer? Are some requests getting rejected? Is traffic even reaching the load balancer network interface? In this scenario, the solution is to enable VPC Flow Logs at the ENI level. With the VPC Flow Logs enabled on the ALB network interfaces, we can capture metadata about every network connection such as source IP, destination IP, port numbers, protocols, etc. Now let's walk through the architecture. In this architecture, we are walking inside a region in the AWS cloud. Within this region, we have a VPC that spans two availability zones. Inside each public subnet, the application load balancer ALB creates an elastic network interface. Client traffic from the internet reaches the ALB. The request is received by one of the load balancers network interface inside the VPC. For simplicity in this demo, the EC2 instances in the target group are placed in the public subnets. In production environment, these instances would typically run inside private subnets. We will be using a security group called EC2SG with following inbound and outbound rule for our EC2 instances. To observe the traffic reaching the load balancer, we enable VPC Flow Logs specifically on the load balancers network interfaces. This means every network connection passing through these ENIs is captured as a flow log record. Once captured, these records are delivered to CloudWatch logs. An IAM role provides the necessary permissions for the Flow Logs service to publish the logs to the CloudWatch logs. We will also be creating a security group called ALBSG for our application load balancer with the following inbound and outbound rule. This network level visibility is extremely useful when troubleshooting connectivity issues or investigating unexpected traffic. Let's scroll and see how the VPC log format looks. We see we have our log format with an example below it. So the first field in the VPC log format will represent the version number of our VPC flow log. Second field will represent our account ID. The third with ENI ID. Following the ENI ID, we have source address, destination address, source port, destination port, protocol, packets, bytes, start time, end time, action, and finally log status. Now let's look into this notes section. We can see that FlowLog captures metadata about traffic to and from the ALB's ENIs. And each log entry shows one of the unidirectional flow as represented below. Suppose we have an incoming request from our client. In that case, the flow would be from client to the ALB. In that case, the source address will be the public IP of our client and destination address will be the private IP of the ALB. Looking into this second flow, suppose our ALB want to send response to our client. In that case, source address will be the private IP of the ALB and the destination address will be the public IP of the client. Moving to our third case, suppose ALB wants to forward our traffic to our target, which in our case is EC2. In that case, again, the private IP will be the source, and for target, again, we will be logging private IP of our EC2 as our destination address. Now let's look into this final flow. In this scenario, our target is sending a response to our application load balancer. In that case, we will be logging private IP of our EC2 instance as source and private IP of our ALB as our destination address. Now let's look into this IP address summary. We can see that we will be logging public IP of our client, whereas we will be logging private IP for our ALB's IP and target IP, which will be EC2 instance in our case. Looking into this last bullet point, we can see that all internal traffic uses private IP only. Now that we understand the architecture and how ENI flow logs capture traffic, let's move to the AWS console and see how to configure this in practice. Now that we are in the AWS console, let's open VPC. In this VPC console, let's click Create VPC. Let's give this VPC a name. Scroll down. For the number of availability zones, select 2. For the number of public subnet, select 2. For number of private subnet, let's select 0. Scroll down, and for VPC endpoint, let's select none and click Create VPC. Scroll down and click View VPC. Under Resource Map tab, we can see we have created a VPC called Demo VPC with 2 public subnets called Demo Subnet Public 1 AP South 1A and Demo Subnet Public 2 AP South 1B. Since these are public subnets, we see both of the subnets route table points to the internet gateway. Now let's move back to our AWS console and open EC2. From the left hand side menu, scroll to the bottom and under Network and Security, click Security Groups. We will be creating 2 security groups for our ALB and EC2 instances. Moving back to our diagram, what we are going to do is create a security group called ALB-SG and security group called EC2-SG. So let's move back to our console. Let's click Create Security Group and give this security group a name. For description, let's put dot. For VPC, let's select our newly created VPC called Demo VPC. Under Inbound Rules, let's click Add Rule. And for type, we will be using HTTP. For source, we will be using Anywhere IPv4 since this is a public ALB. For now, let's leave outbound rules as it is and click Create Security Group. We can see that we have successfully created our security group for our ALB. Now let's go back to our security groups and click Create Security Group again. Let's give this security group a name. For description, let's put dot. For VPC, let's select Demo VPC. For inbound rule, let's click Add Rule. For type, let's select HTTP. For source, let's select custom, and in search bar, let's search for our ALB security group. We can see that we have a security group called ALB-SG. So let's select this. For outbound rule, let's leave it as it is and click Create Security Group. Now again, let's move back to our security groups and let's select ALB-SG. Let's move to this outbound rules tab and click Edit Outbound. Let's delete this default rule. Now click Add Rule. For type, let's select HTTP, and for destination, let's select our EC2-SG. Now let's click Save Rules. We have now successfully created our security group for both ALB and EC2. Now let's move back to our console and open EC2. Under this EC2 dashboard, let's click Launch Instance. Let's give this EC2 instance a name. Under Application and OS Images, under Quick Start, let's select Amazon Linux. For key pair names, let's select Proceed without a key pair. For network settings, let's click Edit. Under VPC, let's select Demo VPC. For our subnet, let's select our subnet called Demo Subnet Public 1 AP South 1A. For Auto Assign Public IP, let's enable this. For Firewall Security Group, let's click Select Existing Security Group. Under this Common Security Group drop-down, let's select our EC2-SG Security Group. Scroll and open this Advanced Details. Under user data, let's paste a command. This EC2 user data script installs Apache and serves a web page that shows the host name of each EC2 instance. Now let's click Launch Instance. Now click this instances. We can see that our instance called server1 has a status check of initializing. Now let's launch another new EC2 instance in different subnet. So let's click Launch Instances. Let's give this instance a name. Let's repeat the same process. Scroll down. For key pair name, let's select Proceed without a key pair. For network setting, let's click Edit. From VPC dropdown, let's select Demo VPC. For subnet, now let's select Demo Subnet Public to AP South 1B. For auto-assign public IP, let's enable this. For firewall, let's select existing security group. In this dropdown, let's select EC2SG. Scroll down and let's open this advanced details. Scroll to the bottom and again paste the same user data script. Now let's click Launch Instance. Let's go back to our instances. Right now you can see both of our EC2 instance called server1 and server2 are in a status check of initializing. Now let's go back to our console and open EC2 instance dashboard. From the left hand side, let's scroll down and under load balancing we can see we have something called target groups. So let's click this target groups. Click create target group. For target type we will be selecting instances. Let's give this target group a name. Now let's scroll down and under VPC let's select our newly created VPC called Demo VPC. Scroll to the bottom and click Next. Here we can see we have two available instances. So let's select both of these EC2 instances. Click Include as pending below. Now we see both of the EC2 instances are under review targets. Now let's click Next. So we are in this review and create screen. So scroll to the bottom and let's click Create Target Group. Now that we have created our target group, from the left hand side under load balancing, let's create our load balancer. So let's open this load balancers. In this load balancers dashboard, let's click create load balancer. Under load balancers type, let's select ALB by clicking create. Let's give this load balancer a name. We will be using internet facing ALB, so select internet facing. Under network mapping, in the VPC dropdown, let's select our demo VPC. For availability zone, let's select both of our availability zone AP South 1A and AP South 1B. Both of these subnets will be used by ALB to create an ENIs. Under security group, let's remove this default security group and open this drop down and select ALB-SG. Scroll down and under listeners and routing, under routing action, let's select forward to target groups. Under this target group drop down, let's select our newly created target group called Demo TG. Since we have a single target group, we will be setting weight of 1 so that 100% of our traffic goes to this target group. Now scroll down and click Create Load Balancer. Right now we can see we have a load balancer called Demo ALB which has a status of provisioning. So let's wait till the Demo ALB's status changes. Finally, we can see that we have status of active for our ALB. Now let's enable VPC Flow Log at the scope of ENI label. From the left hand side, under Network and Security, let's click Network Interfaces. You can see we have 4 network interfaces currently. So let's scroll and under description we can see we have 2 network interfaces that were created by our demo ALB. Here we can see we have demo ALB and demo ALB. So let's select both of these network interfaces and click Actions and click Create Flow Log. Let's give this flow log a name. For filter type, we will be using all. For destination, let's select Send to CloudWatch Logs. For destination log group, since we haven't created any log group, so let's go to our console and create log group for this. Let's open CloudWatch Logs. In this CloudWatch dashboard, let's select Log Management under Logs. Click Create Log Group. Let's give this log group a name. Scroll to the bottom and click Create. You can see we have created a log group called /AWS/VPC/FlowLogs/ALB/ENI. Now let's move back to our Create Flow Log screen. For destination log group, let's refresh this and choose our newly created flow log called /AWS/VPC/FlowLogs/ALB/ENI. For service access, let's select Create and use a new service role. So what this does is, moving back to our diagram, it creates an IAM role for our ENI flow logs automatically. Now scrolling down, now let's click Create Flow Log. We can see that we have successfully created our flow logs for two different network interfaces that were created by ALB in the public subnets. If we select our first ENI and under flow logs, we see we have a flow log named VPC Flow Log Demo ALB. Now let's select our second ENI and click Flow Logs tab, and again we have a VPC Flow Log Demo ALB flow logs being created for this ENI too. Now let's go back to our load balancer and let's call this application load balancer using this DNS name. Let's copy this DNS name and in new tab, let's open this. You see we got hello from IP 10.0.29.222. So let's refresh this page multiple times to see if both of our EC2 instances are working properly. Indeed, you see hello from IP 10.0.11.142. So both of our EC2 instances under our target group connected with ALB is working correctly. Now let's go back to our CloudWatch and see if our VPC flow logs has been captured for our ENIs. Under this log group, let's select our log group called ALB-ENI. Under log streams tab, we can see we have two different log streams created for our two different ENIs. So let's match these ENI IDs from our network interfaces dashboard. So let's copy this and move back to our network interfaces dashboard and let's search for the ENI ID. Indeed, we see we have the ENI with the same ID associated with our demo ALB. Now let's do the same for our another ENI. Let's copy this and let's search for it, and again we have exact same ENI ID which is associated with our demo ALB, which shows that we are creating proper flow log for our correct ENIs. Now let's move back to our CloudWatch and let's select the first log stream. You see we have multiple flow log records. So in order to make it simpler, let's go back to our diagram. Under this VPC flow log format, let's look into this unidirectional flow and see for client to ALB traffic. First of all, let's find out our public IP. We can see that I have public IP of 113.199.231.100. So let's copy this IP and in CloudWatch under filter events, search bar, let's paste the IP address. Let's search for this IP. You can see there are multiple records with this public IP. Now let's open this first record. You can see we have public IP of 113.199.231.100 as source address, and for destination we can see this value of 10.0.25.65. So let's check if this IP address matches one of our private IP address of our ENIs. So let's copy this value and move to our network interfaces, and let's search for this value. Indeed, we can see that this private IP matches to the ENIs of our ALB. This shows that we have successfully logged our flow from client to our ALB. So this number 1 is checked. So let's look for this second directional flow. Let's move back to our CloudWatch. Now let's look into this second record. Here you can see that we have private ENIs of our ALB at source and public IP of my laptop as destination. This log record proves that our second flow is working correctly. Now let's move back to this number 3 and see if we are recording this flow. Now let's go back to our CloudWatch logs again. We know that we have ALB's private IP of 10.0.25.65. So let's copy this and paste it and click enter. Now let's open this first record. You can see that we have source of 10.0.25.65, which is the private IP address of our ENIs, and for destination we see this IP address which we haven't seen till now. So let's copy this IP address. Let's go back to our instances tab and let's select our server 1 and let's search for this IP address, and indeed it's the private IPv4 address of our server 1. So this again shows that we have recorded this third case where we are logging record from our ALB to target. Finally, let's look into this case 4. We want to see if our response from our EC2 to our ALB is recorded. So let's move back to our CloudWatch. Now let's copy this private IP address of our EC2, and under this search bar let's paste it and search for this IP address. Now let's open this second record. We can see that we have our private IP address of our EC2 as our source, and for destination we have a source IP of 10.0.25.65. So let's copy this IP address, move back to our network interfaces, let's search for this thing, and indeed that's the private IP address of our one of the ENIs. Moving back to our diagram, we can see that we have indeed successfully recorded our log from our EC2 instance to our ALB. That's it for this demo. To prevent unnecessary cost, let's remove our resources. Let's move back to our instances tab. Let's select both of our instances. Under instance state, let's click terminate delete instances. Let's click terminate. Let's move back to our target group. Under actions, let's click delete. Right now we are failing to delete this target group called demo TG. So before deleting this target group, let's go back to our load balancer and delete this load balancer instead. So let's click actions and click delete load balancer. Let's confirm. Let's click delete. You see now we have deleted our load balancer. Now let's move back to this target group. Let's select this demo target group under actions. Let's click delete again. Now we can see that we have deleted our target group successfully. To wrap up in this video, we enabled VPC Flow Logs on the load balancer's network interfaces and sent those logs to CloudWatch. This allows us to observe the actual network flows reaching the load balancer and better understand how traffic moves through our architecture. These logs are especially useful when troubleshooting connectivity problems or investigating unusual traffic behavior. I hope you found this helpful. Don't forget to like, share and subscribe for more videos like this. Thanks for watching.